no schedule yet for which mock exams you're taking on which days, but of course you know 2 separate days for the math because there's 2 papers. And I'm sure your other teachers have probably told you how many different papers there are for science, for and that stuff. So yeah, so that's for that. Let's. I have your homework, so I think we'll definitely finish going over paper 2 of the mock exam that we took already today, and then I didn't grade these, but I'll give them back, and we'll go over any questions from this today, and hopefully that means we'll be ready for tomorrow to start on the last chapter, the final material that we need. I think it's been really good for us to go over the exam, because I think, like, especially yesterday, especially for the new kids from this year, that the upper bound and lower bound stuff that you didn't learn, all those things in your things to remember page. What I am going to tell you is that for tomorrow, as part of your homework, I'm going to want you to take what you wrote down on your things to remember page and write it again and hand it in to me tomorrow, so that I can see that everybody is keeping a reasonable things to remember page. Meaning, if I know that you're someone that didn't do well on the exam, on the exam that I did that we're going over, and you don't have much of anything on a things to remember page, then I'm gonna get on you about that, okay? Because that's a really good thing to help. Because at this point, it's not about getting you learning new things and getting you into trouble for not doing your work. At this point, it's just preparing for the exam, except for this last chapter. So I'm not going to be crazy with homework, except we're going to be doing a lot of reviewing after we finish this last chapter. The things to remember, yeah, the things to remember page, you're going to keep the one you have in your book, and then you're going to write me a new one, hand it in. So in other words, you still have the one in your book, and you're going to hand me the new one. And then you're going to continue to add to it as we do more practice exams and continue to go over those practice exams. Shinha never came in today? Okay. I also want to remind you about the Night of the Arts. I know many of you are talented in this class. Yes. Today at 1:10 will be a meeting for visual art. If you have something, Nicole better go. Right? You're a visual artist, right? No, weren't you in it last year? And you made that nice picture for me. I know you made a lot of nice things. Cal, you did something last year, right? Anyway, so for dance also, I wish Chinha was here, because I really do think that if you're a good dancer, you should go to the meeting and see if there's something that you want to do on Thursday. You know, there's also a hip-hop class after school program starting. So I think it's on Tuesday. But you didn't sign up yet? You might still be able to sign up. If you like to dance, and I don't know if you weren't even really into the dance last year so much. But those of you who are, I know Risako was into that last year, but anyway, let's go over the rest of the text. Did I give you chocolate yet?
No.
Did anybody want to sign up for this? If you didn't already?
I never really understood how it works.
You're not that popular.
You don't understand the way it works, really?
Like the whole page?
Yeah,
Whenever I don't have anybody, your parents can come at any of those times. You have to sign up, but you have to make sure that that you'll be there.
Almost a minute.
So, and write down the time, and I have to sign it on your page. Okay. Okay. Please take out where we left off. Yes. If there's an available time. The time that I have here for you is 6:10 to 6:20. Your parents can't make it at that time?
Yeah, they can.
What?
Como en Conchauquillo. Ah, que
Oh, okay. What time? The times that I have available, the whole afternoon is filled, but the evening, I have 6:20 to 6:30, which is 10 minutes after the one you already had, and anywhere from 6:40 to 8 o'clock. 6:40 to 6:50. Okay, come to me and I'll sign it after. I'm going to erase. When do you want to do it? You can do 6:10 to 6:20 if you like, or 6:20 to 6:30. Which one? Okay. Just write my name and on 6:10 to 6:20. She's taking your old time now, so we can't go back, Ellen. Yes. No, I'm just going to select it. What about your other teachers? Okay, so we left off. We left off on number 13, and 13 is a good one. I'm glad that they gave you a problem on that, because that's something that I think we might have had trouble with. First thing I want to review before, please stay with me and where's your notebook? Where's your things to remember page? Mo, get on the game. Just want to remind you something about things being proportional. We said we have direct proportionality and we have inverse proportionality. Now, conceptually speaking, direct means as something increases, something else increases. As something decreases, something else decreases. Inverse means that one thing increases, something else decreases, and vice versa. So this means, first of all, is proportional to, and I saw some of you used it. So direct proportion, if y is directly proportional to x, then we say it looks like this. And that means that y is equal to some constant times x. This says y is directly, and you don't really have to write it, but I want you to know the word, even if you just say it's proportional to x. This means y is directly proportional to 1 over x, or y is inversely proportional to x. Okay, remember, this is saying y is proportional to 1 over x, but that's the same thing as saying that y is inversely proportional to x when you write it like this. And when we put the constant, it's y equals k over x. And that's the same thing as saying xy equals the constant. Now k, the constant, is just some number. Okay? Anyway, these are just things to remember. But now let's look at the example. A spray can is used to paint a wall. The thickness of the paint on the wall is T. The distance of the spray can from the wall is D. T is inversely proportional to the square of D. Now, when I first did it, I read it quickly, and I said T is inversely proportional to D, because I didn't read it carefully. I just saw inversely proportional, saw D, and did it without thinking about it. But it's actually inversely proportional to the square of D. So you can write it this way if you use that sign. This means T is equal to K over D squared, which is the same thing as saying TD squared is equal to K. Okay? I think you would have got a point just for writing one of these things. Now, it says t is equal to 0.2 when d is equal to 8, and we want to find t when d is equal to 10. So this is something we know. This is going to tell us what the constant k is. So use either of these to help you find k. I'm going to use this one. So we know that 0.2 is times 8 squared is equal to k. If you put that into your calculator, what do you get? 12.8 or 128? What is it? 12.8 is the constant. So now you know that the actual relationship is TD squared is equal to 12.8. This equation represents the relationship of T to D. Sorry, T to D, but also T to D squared. So when D is 10, I'm going to put 10 in here. So T times 10 squared is 12.8. 100T is 12.8. If we divide by 100 on both sides, T is equal to 0.128, and that is the answer. Now, if you ended up having to do this where you took the square root and you got an answer, when you take the square root, you might have a positive or negative answer. But if you're talking about something like time or distance, there is no such thing as a negative. So you would just take the positive. In this case, you don't have to worry about it, but I'm bringing it up anyway. How many of you got that right? Okay. And if you made a mistake, ask me a question. I can help you. Yeah. Yeah. There's no reason to round. It's an exact answer. It actually has 3 significant figures. You rounded it to 2 significant figures. No, that's 2. 0.13 is 2 significant figures. We're still having trouble understanding significant figures. This 0 is irrelevant. It's not significant. The only time the 0 would be significant is if you had something like this, 0.1295. First of all, if that's an exact answer, you leave it. You don't round it. You only round irrational numbers that have long decimal places. But if it was this and had a lot of places, it would round to 0.13, and then you'd have to put the 0, because that's significant. That's when it's significant. This is not significant. You see the difference? Also, if it's 0.1025, blah, 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 that would round to 0.103. This is significant because it's a placeholder, so it is significant. But you don't round 0.128 to 0.13. But even if it had another decimal place, or 2 more after it, if it's an exact answer, you don't round it. Okay?
2 0 at the front is not ever a significant.
It would be significant if there was a 5 here. If it's 50 points, then it would be, the 3 significant figures would be 50.1. You see the difference?
But it's low.
No. Yes.
If online the calculator, it has like a 6 or 7 numbers at the back, but like you stop there and you like in something or you
If it's irrational, so if it's the square root of some number,
no, that goes like forever. This is what it has like 6, like it stops, but then it has like 6 or 7 decimal points.
and it's exact, you're saying?
Yeah. So do you write 4?
You should write it. I mean, let's go back to the front cover. Okay, let's read it again so we understand. Because it says it in the directions here. It says, if the degree of accuracy is not specified in the question, and if the answer is not exact, give the answer to 3 significant figures. So when is it not going to be exact? It's not going to be exact if it's the square root of some non-perfect square. It'll be some long decimal. When else? If you use pi. But you don't even need to use pi because they let you use 3.142 for the whole test if you want. But you could use pi also. Also, if it's the sine or cosine or tangent of some degrees, that will give you some long decimal that's irrational. So even that, you would round. Okay, so those are really the main times you would round. You know what? Even though it says that, and I don't know if I even want to tell you this, but I guess I will tell you it. Sometimes they still let me give you points. Paper 2. What number is this? No, not that one. But if there's another problem that tells you to round, I have to find an actual problem. I know in paper 4 there were a bunch. I think even if you did get an exact answer, sometimes they gave you some leeway to round it, even though they didn't tell you. But I wouldn't count on that, because that's this paper. And another year, they might have said that they can't give you credit if you rounded it. So just follow the rules that they said. And all the rules are right in the front. It's right on the cover. If you don't remember, go back and read it. Okay? But we're going to do so many of these that I think you know it at that point. Although we've been doing it since the beginning of last year, and we're still not really getting it. So let's keep practicing it. Okay. Next. Okay, number 14. There are 10 to the 9th nanoseconds in 1 second. Now, whenever it says something like that, I write out the ratio. 10 to the 9th nanoseconds is to 1 second. Actually, that's equal. I'm sorry, that's actually equal. It's not a scale factor, right? It's actually true. It's always true. It's not just, if I said on a scale that 1 centimeter represents 10 meters, we know that 1 centimeter is not equal to 10 meters, right? But I would write the ratio for that. I would put it as a ratio. This is an exact. If I said 1 kilometer is equal to 1,000 meters, I would actually put equal. I wouldn't put the ratio. And that's something you should know. You would never lose points for that. I mean, if you put it down equals or ratio, it doesn't matter on the test, but I'm trying to show you the really correct way to do it. Anyway, find the number of nanoseconds in 5 minutes, giving your answers in standard form. Okay, here's another time, and again, on Things to Remember page, I would put, you didn't get an eraser yet, John? On the Things to Remember page, I would put dimensional analysis. I think it would help you. Anyway, we want to convert 5 minutes is how many nanoseconds? Well, I'm going to take it one step at a time. I'm going to change minutes first to seconds, right? And then you see how I position the minutes on top and the bottom here so they will cancel out. So I know that 60 seconds are in 1 minute. And now I have seconds, but I want to cancel out seconds and change it to nanoseconds. So I know that there are 10 to the 9th nanoseconds in 1 second. So I'm going to multiply 5 times 60 times 10 to the 9th, and this denominator will just be 1. So use your calculator. I'll do it with you, because here might be an example that you're going to see something written as in standard form on the calculator. So 5 times 60 times 10 caret 9. We all know how to use the caret button. And I see that it is written in standard form here as 3. And you can leave your answer like that. 3 times 10 to the 11th nanoseconds is your answer. You don't have to write nanoseconds. You just have to put the number 3 times 10 to the 11th. If you felt like changing it, you could, but I don't think it's in your best interest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, comma, comma, comma. It's 300 billion. Because you did it wrong. You did 300. 300. This, okay, see, she wrote this, and this is a good lesson. She wrote 300 times 10e9. Okay? 10e9 is 10 times 10 to the 9th. We want, if you're going to write it with e, you should write 1 times 10 to the 9th. What I wrote is, well, she did 60 times 5 first, but I wrote 5 times 60 times 10 caret 9. You forgot what e means? If I'm going to write...
No, what can you find e is?
EXT on the bottom.
Oh.
Okay, write that down. Write that down. On your things to remember page, Chung,
Yeah.
write this. 5, and you can put this to know it's the button, is the same thing as 5 times 10 to the 9th. And on the calculator, this will actually look like just an E. It won't put EXT, it'll just come out as an E. Again, a lot of you might think, oh, I don't need to write it on my things to remember page because I'll remember it. But you might forget it. So don't expect to remember it. Write it down. There's nothing wrong with writing it down. Yeah. Ah, thank you. So this is wrong because I didn't read what it said. It said to leave your answer in standard form, so you must leave it like this. Yes. Standard form, you have a number times 10 to some power. This number must be, I'm going to call it x, must be greater than or equal to 1, but less than 10. What does that mean? It means you cannot have 2 digits in the whole number. So you can't write 50 times 10 to the... So 3 times 10 to the 11th is the same thing as 30 times 10 to the 10th. But this is not in standard form, because this number must be with only 1 digit in the whole number place. Only a ones place. You cannot have a tens place. This is also 0.3 times 10 to the 12th is actually equal to 3 times 10 to the 11th. But it's not in standard form. So we put it in standard form because the important thing about seeing something is seeing the power, seeing how big it is. So if we keep this always with just the whole number place, then we can always compare numbers in standard form by how big or small they are by the exponent, by the index of the 10. That tells us. So if you want to know if something like the distance from here to Mars or from here to Saturn, if you write it, let's just say that what's farther away, Saturn or Mars? I don't know. If you see this, and you see this, we really can't compare the two distances because this is not in standard form. Even though this index is higher, this is not in standard form. 500 times 10 to the 10th is 5 times 10 to the 8th. So if this is the way it's supposed to be, then we could just look at these and say this has to be farther away. Good. Okay. So we know that this distance is smaller than this now that we have this in the right place. That's the point of standard form. Same thing with the weight of an atom or of an element. The only difference is the index will be negative, right? 5 times 10 to the negative 4 is 0.0005, right? It tells you how, because remember, 10 to the negative 4 is 1 over 10 to the 4th is 1 over 10,000. So it's 5 10,000, which is written that way. Remember I showed you how to move the decimal. Good question. If you had 3.5 times 10 to the negative 4, you weren't here when we did this last year, but 3.5 is 10 to the negative 4. You don't just add zeros. That's not the way it works. We move the decimal. So 3.5 times 10 to the negative 4 will move the decimal 1, 2, 3, 4 places, and in these bowls, we put zeros. It's the distance from the decimal to its new place. So this is equal to 0.00035.
But that would be standard form, 3.5.
Yeah. Yeah. As long as the number has to be between 1 and 10, meaning there's only one whole number spot. Okay, it could be 50 decimal places after it, but it must have only one whole number spot.
Can you go over dimensional analysis? Well, like, yeah, I know, but an example, another one? I've seen you do it a lot of times.
Okay, let's do one more example of dimension analysis. What?
If you can only have one whole number spot, then wouldn't 0.3 count as?
No. Zero, that means that 0 is not significant in that matter. It would have to be 3 point something. There has to be a number there. There has to be a number. So if I gave you this number, and I want to change it to standard form, my decimal, this is going to have to be equal to 6.1 times 10 to the something. What's it going to be? It's going to be 1, 2, 3, 4, 5. 10 to the negative 5. It has to be between 1 and 10. So don't think of it as something in the whole number. Think about it, it has to be between 1 and 10, not including 10. Notice that. It's here, not including 10. Okay? Dimensional analysis. Let's do one more example of dimensional analysis. Let's change, and we'll do a harder one. 10 kilometers per hour. Let's change it to meters per second. And I'm doing this one because this has both a numerator and denominator that needs to change. You should write this down if you're not getting it, especially on your things to remember page. So the first thing, I'm going to write 10 kilometers per hour. Now I got to think, what do I want to change first? I have to change kilometers to meters, and I'm going to have to change hours to seconds. So you decide what you want to change first. So if I want to change the denominator first, let's say I want to change hours to seconds. Well, first, I want to cancel out hours. So I'm putting hours on top, and I'm going to change it. On the bottom, I'm going to put minutes. That gives me 1 hour, I know, is 60 minutes, right? Are you with me? Now, I canceled out hours, so I have kilometers per minute, but I want seconds. So I'm going to multiply it again by, I'm going to put minutes on top to cancel these out, just like fractions. When you multiply, you can cancel, and I'm going to change it to seconds. So I know 1 minute is equal to 60 seconds. So now I'm left with the minutes canceled out, and I'm left with kilometers per second. Now I got to change kilometers. So I got to put, kilometers is on top here. I want to cancel it out, so I'm going to put kilometers on the bottom, and I'm going to put meters on top. Now on the bottom, we know 1 kilometer is 1,000 meters. So then I'm going to multiply 10 times 1,000 divided by 60 divided by 60. And that will give me meters per second. And again, that's dimensional analysis. And that's a harder one, but because it has 2 dimensions. It has kilometers and hours as a dimension of distance and a dimension of time. Any other questions before we move on? Okay, part B. This next part is really testing your calculator use. Okay? The next part is really testing your calculator use, and it's including using that exponent, that EXP button, which gives you standard notation. No, you don't. But I don't know why you wouldn't. It's so easy when you use a calculator. So instead of trying to do it manually, if you can realize, you'll see now when we do it. It says 5 bracket x plus 3 times 10 to the 6 is equal to 4 times 10 to the 7. So I'm just going to set this up and solve it like I would solve any equation. So please watch. First, I'm going to divide by 5, and I'm going to keep this in brackets, because I know that this I'm just going to put in the calculator as 4 exp 10 to the 7. 4 exp 7, right? So this divided by 5, and I'm left with x plus 3 times 10 to the 6 is is equal to, and if you want, you can put that in the calculator. Now, I'm going to use brackets. Use brackets, please. Bracket 4exp7, close bracket, divided by 5, and it gives you 8 million. Now, you can write 8 million, or you could write 8 times 10 to the 6. It's up to you. And then I'm going to subtract this. This is equal to 8 million, or 8 times 10 to the 6, minus 3 times 10 to the 6. And I'm just going to put that in the calculator. I'm just going to, actually my answer is there, so I'm just going to hit minus, and in brackets I'm going to put 3 exp 6, close bracket, and I'm left with 5 million. And do they want the answer in standard notation? No, it doesn't specify. So you could write 5 million, or you can write 5 times 10 to the 6. But that's really good that we see this problem, because it's good to practice using that button, and please write it on your things to remember page. Now, if you got it right, but you didn't use the button, then write how to use the button on the things to remember page, because it's not just about getting it right or wrong, it's about finding the fastest and best way to do it. And even if you do it the hard way, you can always just check it using the other way. Okay? Now, number 15. Number 15 is interesting because we've done so many problems like number 15. Except, in number 15, the problems that we did were much harder than that. Why? What made the problems harder in the textbook than the problem that they gave you here? Yeah, they didn't give you a drawing. They just told you this guy is standing on the tower, and he's looking down at someone there, and then he's looking down at someone there, and you had to understand that it's three-dimensional, and you had to sort of make a drawing, right? But now, because of all that practice, because of that work that we did, hopefully the easier ones, we see, they should come a little bit more naturally. I think a lot of you got this one right. Mahmoud is working out the height, h meters, of a tower VT which stands on level ground. He measures the angle CAB as 25 degrees. He cannot measure the distance AB, and so he walks 80 meters from A to C, where angle ACB is 18 degrees, and angle ABC is 90 degrees. Calculate the distance AB. Well, all they just did is tell you what the drawing is showing. I mean, really they could have just showed you the picture and said, find the distance AB. But they put all that other stuff in there, which you should read. You should read it anyway. So first they ask you to find the distance AB. So the first thing I did for part A is I put an N here. That's what I want to find first, and then it says find the height of the tower VT, which is H. Now, again, if I were them, me liking to get a little bit more difficult, I would not ask you to find this first. I would just say find the height of the tower, and you'd have to realize, well, what can I find first? Okay, but they're giving it to you, right? They're telling you first find this, and then when you have this, you can find the other one. Problem is, if you don't know how to find N, then you're screwed for both parts. And this is a 4-point problem. So to find N, I see that this is a right triangle, flat on the ground. So I'm going to say that the sine of 18 degrees is opposite over hypotenuse. Sine of 18 degrees is N over 80. So 80 sine 18 degrees is N. There's three significant figures. What do we get? You get 24.7. But actually, I wrote it like this. First, and then I wrote on my answer line 24.7. So this is something you would have to round, these significant figures. Why did I write this down?
For the answer here.
Yes, for the next part, I'm going to have to use this number. And I don't want to use my rounded number. I want to use a few more decimal places to be more exact. Okay? Because even though I'll round in the end again, I want to use a more exact value of n to help me find h. So for part B, to find h, now I know that I have 25 degrees, this is the opposite, and the adjacent. So tangent of 25 degrees is equal to h over n. So h is n tangent of 25. And you know what? You don't even have to put this number in because the answer is still left on your calculator. So you could just take the answer and multiply it by tangent 25 degrees and then round that answer. Or you could put 24 and put a few extra decimal places times tangent of 25. So what's h? Round to 11.5. Now let me look at the answer to this one. This is 16. See, they just put 11.5. So what happens if you put 24.7 times tangent 25? You still get the same answer. Okay. But I don't know what they would do if it could make a difference. So I always tell you just to be on the safe side, use more decimal places, or just, you could have even put 80 sine 18 times tangent 25. That's what n is equal to. Anybody have a question on that one? This one everybody got wrong, except for one or two people. And it's interesting because I don't really blame you for getting it wrong. Because when I taught it the way what the book had. I didn't teach it. I didn't teach this. I probably taught it, but I didn't emphasize it as one of them. I showed you all these ways, all these loci, right? I told you the distance from a point would be a radius of a circle, right? Would show you a circle. You know, let's just go through them quickly, all the loci, and then we'll talk about this one. Did anybody get full credit? Anya? So what are the loci? We know the distance, and I'm just going to write it quickly. If you know you had trouble with it, write these down. Loci. Locus is one, right? Loci is all of them. So the first one is the distance from a point. The distance from a point is a circle, right? With whatever that distance is. So everything that's 5 centimeters away from this point would be the circle around it. Second one we learned is all points equidistant, let me do it like this, equidistant from 2 points, meaning the same distance away from 2 points. It's the perpendicular bisector of the lines connecting them, right? This is the same distance away from these 2 points, A and B, right? Every point. This is the same distance away from A and B. This is the same distance away from A and B. So all points are the perpendicular bisector between those 2 points, and you have to use a compass to do that. Okay? There's no just drawing it. You must use a compass. The third one, everything that's a certain amount of units away from a line. Well, if it's, let's say it's 1 centimeter away, it would be this, and here it would be a semicircle of the same radius, right? Of whatever this distance is, we'll call it d. The distance away from any point on this line. Does everybody remember that? Equidistant from two rays of an angle would be the angle bisector, right? This is the same distance away from both of those lines. I think those are all of them. No, then we just had from two parallel lines. If I give you two parallel lines and I want to know what points are the same distance from both of these lines, it would be another parallel line going forever in both directions, in between them. So it's the same distance from here to here. Sorry? Thank you. And the last one, which I usually teach in New York, but it didn't have it in our book, but two intersecting lines. If you have two intersecting lines, and you want to know all points that are equidistant from two intersecting lines, that's pretty much the same as number 4. It's going to be an angle bisector. Here, every point on this line is the same distance from the angle bisector, from both lines, right? And this angle bisector. And this is the problem they gave you. They asked you to find, let's read it, using a straight edge and compass only. Draw the locus. And now, please remember, when you're told to use a compass, you are to leave all markings from the compass. If I don't see the markings, I have to take off the points. Here, all the arcs drawn from the compass. It says at least two, all the arcs must be, but for one point you have to draw the correct bisector. For another point, at least 2 arcs drawn on the arms and 1 pair of correct crossing arcs. And I'll explain what that means. And the same for the other 2 points for the second one, because there are 2. So it says, draw the locus of all points inside the quadrilateral ABCD, which are equidistant from the lines AC and BD. So here you have this quadrilateral. Something like this. Here is, and they connect these lines. And we want to know the locus. We want to draw the locus of points inside the quadrilateral that are equidistant from AC and BD. The same distance away from both of these lines. So, where's the compass? There it is. So, what do they mean by all the arcs? Well, that we want to draw the angle bisectors. So, here. First, what you should have done is drawn one arc like this, and then from here, an arc, and here, an arc. And you should use a ruler. Do we have a big ruler here? And now you just have to connect from here, but you can just connect it all the way through. From here and all the way to the other end. So you're going to connect it all the way. So this is the first locus. And you don't have to make a dotted line. I always make a dotted line just to show that that's the locus. And then you would have to do the same thing for the other angle. So here, I would draw this, and then from here, and here, and this point will connect and go all the way through to there. Now I know if they gave you any other locus, any of the other ones, I know most of you will get it right. But this is the one they gave you. But that's good. I'm glad they gave you this one now, so next time you don't have to worry. I'm just going to freehand it. This should go here, and again I would make a dotted line, and those are the locus of points inside the quadrilateral of all points equidistant from the lines AC and DB. Questions? Well, let's pick a point. Right here. This is the same distance away from here and from here, from the two lines. This is another point. It's the same distance away from here and here. This is the same distance away from here and here. Since you still don't understand it, this is the same distance away from here and here. I could do 3 more examples. I'll be right back.
I know you're thinking. Maybe. Yeah.
Ready? Bring up! Be funky. 17. A lot of people got part A wrong. And most of you got part B right. Which is funny, because I would have thought it to be the opposite. I would have thought that the rotation would be the harder one. And the reflection would be easier. But a lot of you thought that the first thing that happened in part A was that it was a rotation. And you have to be careful. Okay? Look at the most important thing that you should realize. I'm going to draw it because I really want you to see it. Okay. If this was a rotation, then you have to realize what would happen to this. This would be on top if it rotated. This long edge would be on top. Okay? It wasn't on top. This flipped. And part of the reason I think it was confusing was looking at the letters. I think without the letters, it might have been a little bit easier to see. I don't know. I think so. Because I also looked at it for a second and thought at first it was a rotation, and then I went through the process of, no, it can't be, and then I fixed it, but no, I took the whole test myself, and then I checked my answers at the end.
What was his goal?
I may have made one or two little mistakes. Yeah, the locus I know though. I told you I teach it that way. The ones I got wrong, it was either calculated mistake or there was another one on this one that I made a mistake on. I think the circle one, it took me a while, it took me a longer time to do the circle one. Anyway, so what you should have realized is that this reflected, you didn't have to draw these lines, but I just want you to see, over the line, y equals x. Now, when it says to say it completely, if you just wrote the word reflection, it could not give you the point. You had to write reflection over y equals x. You had to write both of those things. Does everyone see that? Okay. Junmo, are you with me? Are you with me? Okay. Then it says to rotate this 90 degrees, rotate triangle A 90 degrees clockwise about the point 4, 4. So, what I did, and I don't know if you did the same thing, I went point to point. I said, well, from the center to here is 2 to the left. From the center to here is 3 to the left. And from the center to here is 3 left, 3 up. And now I just have to change these directions to be 90 degrees clockwise. So left, 90 degrees clockwise will take me up. This will become 2 up. This will become 3 up. This will become 3 up and 3. Now up, 90 degrees clockwise, will go right. And so this went 2 up, 3 up, 3 up, 3 to the right. Most of you got this one right. And you should see, when I did it, what did I do? I actually underlined the word 90 degrees and underlined the word clockwise to make sure I didn't make a mistake. I even looked what I did. And this is not for you, this was for me. When I did it, I wrote this. I wrote 90 degrees, and I went and I did this to show that it's clockwise. That's how I help myself to make sure I don't make a mistake. Yeah. Yeah, the exact style of the same amount of time. I mean, you did a mock exam with me already, so you're going to do another one, which is good. I'm happy because I would give it to you anyway. The other thing is that other times it's hard for me to give you mock exams because I have to ask other teachers to switch with me so I can be here with you so you can have your 2.5 hours, and it's not easy for me to set it all up. But at least I think it's good for you to have that time. Okay, because I want you to know what it's like to sit through this exam. And like I said, most of you did pretty good for without revision and without learning a full topic. What do you mean? I don't know what room you'll be in. You'll probably... That's not the test. That's to keep material. So when we get all your tests, we put it in that room and lock it up. It becomes a secure IGCSE room that only the people who are registered are allowed to go into that room. Yeah, you can't get in. You're not smart enough. Okay, next. Number 18. You know, I love seeing you get this one wrong. And even the ones who really think they're so smart make mistakes. And did you get this right or wrong? And I went through this. First, I want to remind you, when you talk about a scale factor, when you talk about something having a ratio or a scale factor of similar figures having a scale factor, what unit are we talking about? Okay, one dimension, which is what? What do we call that? No. No, one dimension is it. Unit or length or distance, right? Or height or width. Just one dimension. When two things are similar, we say that their scale factor is it relates the side of one to the side of another. Now, if it's a vase, it could mean the height or the length or the width of the vase to the height, length, width of the other vase. Yeah, say vase or vase. Both. So, realize that first. Now, I know after you go over this, you're like, oh yeah, because we went through it. Remember how we said that 1 meter is equal to 100 centimeters. That does not mean that 1 square centimeter is equal to 100, 1 square meter is equal to 100 square centimeters. Okay? You would have to square these. So 1 squared meter square is equal to 100 square centimeters squared. So 1 square meter would equal to 10,000 square meters. And 1 cubic meter would be this cube, which would be 1,000,000 cubic centimeters. That's the same with ratios of similar figures. So let's look at this. Here is a triangle. This is a 1 by 2. And let's say that this is a 6 by 3. You don't have to write yet because you should write something afterwards. So these two figures have a scale factor of 3 or a ratio of 1 to 3. We agree, right? But their areas do not have the same ratio. The areas are in the ratio 1 squared to 3 squared or 1 to 9. And I'll prove it to you. What is the area of this triangle? 2 times 1 divided by 2 is 1. This is 1 square unit. We'll call it square centimeter, right? Let me see that, right? Because you said the wrong number before. Everybody heard them? Said it wrong. What's the area of this? Base times height divided by 2 is 9 square centimeters. Okay? And the volume, if this was a solid, if it wasn't just a flat surface, if it was something like a vase, then the volumes would be the cube of their scale factors or of their ratios. Do you remember doing that? Do you remember when we did that in this book? So now you should be able to do it, but let's go through it again. 2 similar vases have heights which are in the ratio 3 to 2. So the heights are in the ratio 3 to 2. Obviously this is the bigger and this is the smaller. A. The volume of the larger vase is 1,080 cubic centimeters. Right away when it says volume, I'm going to say that the volume, the ratio is going to be 3 cubed to 2 cubed, which is 27 to 8. That's the first thing I did. Then I set up a proportion. Larger to smaller. I know that the larger volume is 27, so the smaller volume is 8. The volume of the larger one is 1,080. What's the volume of the smaller? Now, all of you did this using not all of you, some of you got it right, but most of you did it using this ratio. For both parts, for both the area, the surface area, and the volume. And I couldn't give you credit. You have to lose a point. Anyway, you find this answer, you get x is equal to 320. Please again, remember the trick. You can do this times this divided by this. So that's part A. Part B, it says the surface area of the, so now we're talking areas. So instead of being 3 to 2, it's going to be 3 squared to 2 squared. Now, be careful, because if in the beginning they told you that two similar vases have volumes in the ratio 3 to 2, then you would have to take the cubed root to find the ratio of the size. Do you hear what I'm saying? So here they gave you this is the height, which is one-dimensional, and we could square and cube it to get the volume and area. But if they said to you from the beginning that the volumes are in the ratio 27 to 8, in order to find the area, the ratio of the areas, we first have to take the cubed root of these. So first you'd have to find the ratio of length, which is one dimension, the cubed root of 27 to the cubed root of 8, which is 3 to 2, and then we'd have to square them to get the ratio of the areas. Now they didn't ask you this, I'm just showing you this, that they could have given you the volumes, or they could have given you the areas and then said find the volumes. If they gave you the area, you'd have to, the ratio of the areas, you'd have to take the square root and then cube it to get the volume. Is that clear? Lane? Your eyes closed? Your eyes closed?
Oh,
You were looking down?
yeah.
Does that make sense? Who got this one right? Anya and Ellen on their game. Don't worry, they got other ones wrong. But the ones that a lot of you got wrong, they're getting right. I have a feeling it's because she's American. You know the Americans are a little bit brighter than the rest of the world. But not just the Americans. We'll say the Americans and the Israelis. To even it out. And the darker skin. The big and funny ears. So part B says the surface area. Okay, so we know that if the heights are in the ratio 3 to 2, the areas must be in the ratio 9 to 4. It says, so then right away I put larger to smaller. You could have put smaller to larger, it doesn't matter. But I set up my proportion, 9 is to 4 as, now which one do they give me? The surface area of the smaller vase, so down here is 252. Calculate the area of the larger vase. So we put X up there. And I wouldn't use X again because I used it. You wouldn't get points off, but again, don't think about, always think what's right. Don't use the same variable for two different things in the same problem. So then this times this divided by this, and you should have gotten 567 square centimeters. And you don't have to put square centimeters because they put it there for you. Okay. But that's another one that I was like, oh, you all fell for the trick, you know? That's one of the ones that it's just a matter of really remembering it. Because if you didn't remember the first part, you wouldn't remember the second part. I think. You got one part right and one part wrong? Okay. And number 19, to my joy and happiness, most of you got this one right. I was really happy. Go to number 19. You want to stand up for the rest of my class? Ming, I better see a good things to remember page. And it better not be the same as anybody else's. How many of you got number 19 right? Most of you did. Now you remember, this is the stuff that we did back at Van Poel, right? We did parts of circles, we did those weird shapes with parts of circles. We did a little bit more this year, and after Van Proof, but at Van Proof we started talking about this kind of thing. And we talked about setting up a plan when you see something like this. Setting up a plan. So, here we have sectors of circles, right? Sectors of a huge circle, and then you have a full circle in the middle. Now there's plenty of different ways that you could have gone about doing this problem. Everybody has a different way, and that's fine. Plenty of ways. So I'm just going to draw a quick sketch of it, so we can talk about how we would set it up. Here you have a circle in the middle, and then you have something like this, and something like this, and we're given some information. We're given that this is 40 degrees. We're given that this radius is 6 meters, and the distance from E to F is 12 centimeters. It says the diagram shows part of a fan with radius 18 centimeters and sector angle 40 degrees. B, C, H, and E lie on a circle, center O and radius 6. Calculate the shaded area. And all of it is shaded. Everything inside here is shaded. So my approach to this was to find these two big sectors, which are equal, because these are vertically opposite angles, and these are both 140, because they make 180, and they all make 360. So my approach to this was, I'm going to find this sector and this sector are the same, because it has the same sector angle and the same radius. So I said I'm going to do 2 times that sector, and then I'm going to add twice this sector. I chose not to take the area of the circle, because taking the area of this whole circle would make it more difficult to find this weird part. You have to do some sort of subtraction. You can. You absolutely can do it. You could have also, not even going to get into it. That was my choice to make. Ning, stand up, please. Stand up. Just move back a little so she can see. Okay, so 2 times the area of these sectors. Well, each of these sectors is what fraction of a circle that would be the whole thing. What fraction would it be? How would I calculate what part of this whole circle that it would be if this was a complete circle?
40 divided by 360.
Yeah, 40 degrees out of the 360 total degrees. Now, you could have done it that way also. I did 2 times, and now I'll just do 40 out of 360 times pi times the radius is 18 squared. Now, what Chang said is, couldn't we just do 80? Sure.
I mean, you put 80.
Oh, I didn't.
Yeah.
That's a 4.
Oh.
That's a 4. You could have actually done in one step 80. It's the same thing. If you didn't multiply 2 times that, you could have said, well, this is 40 degrees of the circle, and another 40 degrees is a total of 80 degrees of the circle. So 2 times, or you could have just done 80 out of 360. So I wrote that, and then I added 2 times this area. Now this area is a part of the smaller circle. It's a sector of the smaller circle. It's 140 degrees out of 360 times pi times the radius squared, and the radius of the small circle is 6. This gave you probably 2 points or 3 points. Let me see what it says, because I want you to see how they're grading it. It said 1 point is to give you the area of one of the sectors. 2 points is to give me the area of one of these and one of these, so finding each of the sectors. 3 points is to add them up, and 4 points is to get the exact right answer. Now when I say 3 points is to add them up, you could have also done it the other way and subtracted, as long as you did it in correct working. Anyway, so if you put this, so I would have simplified this, 40 over 360 is 1/9. So that gives you 2/9 times pi and times 18 squared plus, and this gives you, divided by 2 is 7 over 18. So that's 14 over 18, which actually gives you, this divides to 1 and 9. So 7/9 pi times 6 squared, and I would have added them up. 2/9 and 7/9 is 1 whole. Is that right? No, I can't do that. Can't do that. The point, I would have found this one, found this one, and added them up. And you have to be good on the calculator for that. So I would have done 2 divided by 9 times pi. No, I would have left the pi. 2 divided by 9 times 18 squared is 72 pi. And this would have been 7 divided by 9 times 36 is 28 pi. That gives you 100 pi. 100 times pi is 314 point whatever, which just rounds three significant figures to 314. So Ming, you gave me absolutely nothing on this. You could have gotten a point or 2 points. If you don't put anything down, you lose 4 points. And that's it. You got nothing left. Stand up, Ming. Stand up. Stand up. Don't lean on the desk. What do you mean you did? You did implies past. Still. 314. So if you made a mistake on this, it's fine to make a mistake. This is less important than just giving me something. Give me something, get some points out of it. If you found the area of the circle, you would have gotten at least a point. You would have got something. But if you give me nothing, I can't give you anything either. There's no reason why somebody didn't answer any part of this. No reason. Next. Most of you did all the drawings of the lines correctly, but got the wrong region. So you had this picture. This was the region. More like that. Most of you got the wrong region. Now, how do you find it? Who remembers how I told you to find it? Because I told you 2 ways of finding it. Now, if you have y is greater than or y is less than, you could just look at it and find what region is correct. But what did I show you in order to find the right region? Pick a point and test it in every equation. And the only thing that has to be about the point that you pick? What's the only thing you have to make sure of when you pick a point? It's in a region. It's not on any of the lines. What do you got there? It's got to be in the region. It cannot be on a line. So I pick 0, 0. Usually I pick 0, 0. Right? I pick 0, 0 because it's easy. But if 0, 0 was on the line, I'd have to pick a different point. 0, 0 will tell me if it works or not. So what I did, so I'm just going to draw just a sketch, because I think everybody was able to draw the line. Here's one line. Here's another line. and here is the third line, something like that. This is the line y equals 4. This is the line x plus y equals 6. And this is the line 2x minus y equals 4. That's what they told you to draw. And then it said write the letter R in the region defined by y is less than or equal to 4, 2x minus y is greater than or equal to 4, and x plus y is greater than or equal to 6. So first, if y is less than or equal to 4, that already eliminates everything greater than 4. That's the first thing that I did. I didn't need to use a test point for that. Then I said, now again, this is the x-axis and this is the y-axis. Then I said, let me take 0, 0 and see if it works. So if I put 0, 0 in here, I get 0 minus 0. I get 0 is greater than or equal to 4. Is that true? No. So 0, 0 is not part of the solution to this equation, which means it's going to be the part that's crossed off. If I put 0, 0 here, I get 0 is greater than or equal to 6. Is that true? No. So in x plus y is equal to 6, 0, 0 is not part of the solution, so I'm going to cross that off. And so this is the region that I'm left with. Now, you're lucky because it's only 1 point for that. Most of you got 3 points for the first part because it's just graphing lines, but another time they'll ask you something different where you actually have to be able to do the other thing. You'll have to actually draw the inequalities. You'll have to draw this from the start and then already shade it from the beginning. But just be careful. Question, Chen?
You cannot use it like if 2x minus y greater or equal to 4. Can you just like
The only time you can do that is if it's y. If y is greater than or equal to. So, for example, let's look at this one, okay? 2x minus y is greater than or equal to 4. I have to solve this for y. So I'm going to subtract 2x. I'm left with negative y is less than negative 2x plus 4. And then I have to divide by negative 1. But remember, if you multiply or divide by a negative, it changes the direction. So that will give me y is less than or equal to 2x minus 4. So here is my line. Y is greater than that. Y is less than or equal to that. So the greater part I shaded off. You understand?
So if you come up with minus 1 includes that.
Anytime if you have negative 2x is greater than 6, and you divide by negative 2, that means x is less than negative 3. And you can test points. What's part of the negative 4? Is less than negative 3, right? So if you put negative 4, you get 8 is greater than 6. So that's another thing. If you're going to, but I suggest using a test point anyway, just to be safe. But when solving linear inequalities or inequations, if you multiply or divide by a negative on both sides, you must change the direction of the inequality. Now, that's in the way I solve equations. If you're solving equations your way, where you don't do something to both sides, it just means, I don't know how to word it then. Because you would just change the negative. If it was an equation, you would just change the sign. But if you change the signs, you got to turn. In my way of teaching how to solve equations, you do something to both sides. So I can say if you multiply or divide by a negative on both sides, don't forget to change the direction. Okay? Then sit down. So write a note to yourself. These are called inequalities, right? The less than, the greater than, the less than, equal, greater. Sometimes they call them inequations. Just remember key things of how to know where the region is. And remember, they can also give you a linear programming problem. Now in this one, they didn't. Remember those problems where they gave you all this information, you had to create the equation, the inequation, and then you had to graph them? So I don't think they'll ever give you one as hard as the ones we did, but you have to know how to manipulate, how to create the inequations, and how to know what at least means, at most means, a minimum of, a maximum of. 21. Again, this is very recent, so you should have all got this one right. I think most of you did. How are we doing on time? What's the bell ring? Okay, how many are left? 2 more. Okay, hopefully we'll finish it so that tomorrow we can just get started. Okay, it says, it gives you that A is the matrix, X, 6, 4, 3. B is the matrix 2, 2, 3, 2, 1. What's going on? Is you okay? What happened? You look sick. You don't look sick. Did you bring a medical note or something downstairs? Look in perfect health. Says find AB. So it's just matrix multiplication. AB is going to be X times 2 plus 6 times 2, X times 3 plus 6 times 1, 4 times 2 is 8, plus 3 times 2 is 6, 8 plus 6 is 14, 4 times 3 is 12, and 3 is 15. I think most of you got that right. 2 points. Everybody all right with that? This is AB. You have to write it down here. If you just wrote it up here, I can't give you the point. Then it says B. When AB equals BA, find the value of X. So they're telling you that AB is equal to BA. Well, so I have to find BA. So if I find BA first, I'm going to write BA, and I'm going to put A over here now again so I can look at it correctly. X, 6, 4, 3. So BA is 2x plus 12. 12 plus 9 is 21. 2x and 4. 12 and 3 is 15. So now, I have AB and I have BA. Well, that means this and this must be the same. Well, they are exactly the same. This and this must be the same. So 3x plus 6 must equal to 21. And actually, I don't even need to do 14 equal to this. But it should be true. I don't need to do it, but I could do it and check it, because that'll make sure. If I get a different x here and here, then I did something wrong. Because if these two are the same, if they're telling me they're the same, then all 4 parts of them must be the same. Now, both of these equations, if you solve it, you should get the same answer. Let's do it. Subtract 6. 3x is 15, so x is 5. And here, if I subtract 4, 10 is 2x, so x is 5. Either way you do it, you don't have to do it both ways, but I did it and checked it to make sure that both were the same. What are you doing? It's not funny. It's not funny. Where's your notebook? Where's your your notebook? Let me see your notebook, please. Where's your notebook? Okay. So come to detention every day this week, please. Morning, tea, and lunch. Starting lunch today. 12:50 in front of the teacher's room. And if what happens again with you happens again, if that happens again, it's going to be the same. Jumo, I want you to move your seat to here. That's going to be your new seat. Okay? Not now. Starting tomorrow. You're going to sit there, you're going to move all your stuff out of the desk and sit here. Ming, you're going to move over to that seat. I don't have time to finish this. Tomorrow we're going to finish this. One more question, and we're going to go over the homework. What's your homework tonight? I'm collecting. Now that means don't rip it out. That means rewrite everything in your things to remember page onto a separate paper. I don't care if it's 3 pages long. And hand it in to me. I'm going to look at everybody's things to remember page. Okay? Tomorrow I'll give you back your homework and we'll go over any questions from the homework. Then we just have Thursday. It looks like we're not really going to get into that last chapter before your mock exam. We'll probably just start it though. We'll start the last chapter. We'll have 3 periods. We'll have 4 periods. We'll have 4 periods to really go over before the test. All right. No, the things to remember page is not a homework number. It's just hand it in. I'm going to be periodically collecting it. And I'll even give it back to you. What do you have next? What do you have next? IGCSE, you go down? Okay, you can go down now. Okay, go downstairs. Then get your ICT stuff, go downstairs. Junmo, Shinha, get your ICT stuff, go downstairs, please.
Okay, so now
It's good to see you.
okay.